All right, good morning, boys and girls. Today we're going to be working on Module 5, Lesson 14, and we're going to be comparing fractions today. So before we start with our workbook and some examples, let's just remember that when our denominator, so our denominator is on the bottom, when the denominator is a large number, let's say like 10, it means that the pieces of your whole are now cut into more pieces. So they're technically smaller pieces. So let me just give you an example. Let's say we have 4/10. So that means that our whole, so I'm going to use a tape diagram. Let's see, our whole is cut into 10 pieces. There we go, 5 on this side, 1, 2, 3, 4, and 5 on this side. And so I have 4 of them. So notice how small these pieces are in our whole because the whole is cut into 10 pieces. So those are 10 small pieces. So I'm going to kind of shade in my 4. Versus, let's say instead of cutting this into 10 pieces, I only cut it into 5 pieces. So I'm going to use the same whole. I'm going to just draw it again. But this time, instead of it being cut into 10 pieces, it's only cut into 5 pieces. So even though the denominator is now a smaller number, the pieces are actually larger. So I'm going to use my highlighter to show you how I'm going to turn these tenths into 5. So every 2 pieces, basically 1, 2, 1, 2, 1, 2, is now 1, 2, 3, 4, 5 pieces. So I'm only going to redraw my lines where I highlighted. So I'm not going to draw this little line here. I'm going to instead just draw this one. So 1, 2, 3, 4. So I end up with 1, 2, 3, 4, 5 pieces. So notice that these pieces are larger. And if I look at the shaded amounts, I have 1, 2, I have 2/5 because these are equivalent. 4/10 and 2/5 are equivalent. But you'll notice that these pieces, they're larger. So when your denominator is smaller, so remember that's the bottom number, it means that your pieces in the whole are actually larger pieces. When your denominator is actually a larger number, it means your pieces in the whole, because you have more of them, they're smaller pieces. There's more, so they are smaller. Okay, so I just want you to think about that when we're comparing fractions today, because a couple of them, they want you to explain your thinking. They don't want you to just give a greater than, less than, or equal symbol. They want you to actually explain why you know or how you know one fraction is larger than the other. Okay, so let's do a couple of examples of how you can decide which fraction is larger. So some strategies to compare. Fractions. All right, so we know that one of the strategies is we can draw a tape diagram. So you can draw your tape diagram. And you can compare 2 fractions. When you're drawing your tape diagram, you can either use the same tape diagram to compare, or you can use 2 different ones and draw one above, one below. So let's say I have an example of 1/3 or 1/4, and I'm trying to decide which one is larger. I could draw one tape diagram to compare and first cut it into thirds, maybe. And then say, okay, well, this is 1/3. And then I might want to use the same type diagram to draw fourths, although if it's a little confusing, then I would draw just an example, like the same length tape diagram right below it. So I can use my blue lines to help me. And now cut it into 4 pieces. So now I have 1, 2, 3, 4. And even though they're not exact, I can see that 1/4 is actually less than 1/3. It's a smaller piece. So I see that 1/3 is actually larger than my 1/4. So I could use a tape diagram and say, well, 1/3 is larger than 1/4. The other strategy would be our cross multiplication. So cross multiplier butterfly method. So we call this the butterfly. Let's say I still have 1/3 and 1/4. If I cross multiply these, so I say 3 times 1 is 3, and 4 times 1 is 4, the side that ended up with the larger number is the larger fraction. So I ended up with 4 on this side and 3 on this side. this is actually a larger number. So that means a third is actually the larger fraction. And again, I explained why this works because you can make both of these, well, you could make these the same denominator, and then you'd have different numerators in this case. So let's say I wanted to make these the same denominator. I know that 3 times 4 is 12. So I could convert these into 12ths. So I could say, well, 3 times 4 is 12, and then 1 times 4 is 4. I could do 3 times 4 is 12, and so 1 times 3 is 3. And you can see I now have, these are the same denominator, but the numerators are different. So when my denominators are exactly the same, the larger numerator is my larger fraction. I have 4 pieces out of 12 versus only 3 pieces out of 12. So 4/12 is larger than 3/12. If the denominator is exactly the same, then you're just comparing the numerators. The larger numerator is a larger fraction, but only when these denominators are the same. And that's why cross multiplication works. You're making the denominators exactly the same. And then you have to do whatever you do to the denominator, you have to do to your numerator to make them. So a third and 4/12 is equivalent, a fourth and 3/12 is equivalent. You're making them equivalent fractions with the same denominator. And you can see that 4/12 is larger, so 1/3 is larger, where 3/12 is a little bit less. So you have the tape diagram, you can compare, you have cross multiplication to help you compare. You could also put them on a number line. So if the last strategy is a number line, it depends which strategy you prefer. So if, let's say I had a number line, and let's say I'm still comparing a third and a fourth, so I start with 0, I end in 1. I usually want to put my halfway mark so I know where the half is. Well, if I'm comparing a third and a fourth again, I'd have to kind of think about, well, if I were to break my third, that would be somewhere around here, so this would be a third. But if I were to do fourths, well, a fourth is half of half. So between 0 and half, my fourth would be about here. It's a little bit less than a third. So if I use my benchmarks on my number line, it's kind of like drawing a tape diagram, but instead I'm only using one number line. I can see the fourth is actually smaller than a third. So the third is the larger fraction. It's a little bit farther to the right on the number line. Numbers get larger as you move to the right. So you have 3 strategies. You can choose the one you prefer. If you use cross multiplication, you do need to just explain that when you make the denominators the same, you're now just comparing the numerators, and you can see that 4 is larger than 3. If you're using the tape diagrams, you can just explain that in the tape diagram, you notice that a third is a larger piece than a fourth, or whatever the fractions are. If you're using the number line, you're going to need to still explain how a third is a little bit more than a fourth on the number line because it's further to the right. All right, so now we're going to take a look at our workbook. And you might want to just use these strategies to decide which one you want to use. Okay, so here's our workbook. We are on page 99 in module 5. It's lesson 14. We're just going to compare based on the size of the units. We're going to use greater than, less than, or equal to. And you'll notice that in the beginning, they're giving them to you in word form. So you might want to write them as a fraction. So 1/4 versus 1/5. Now, this is kind of like what I said in the beginning. You know that based on your denominator, if your denominator is larger, there's more pieces, but that means they're smaller pieces. Versus if it's a smaller denominator, they're actually slightly larger pieces. So when we're looking at 1/4 versus a fifth, even though the 4 is smaller, it means your pieces are actually larger. If I gave you 1 out of 4 pieces, it's going to be larger than if I had to split up a candy bar, for example. With 5 people, you're going to get a smaller part. So if I had a candy bar and I was only going to have to share it amongst 4 people, you get a slightly larger piece versus if I had to share it with more. So I know that 1/4 is actually larger than a fifth. We're going to do this one, 3/4. I might want to write it again versus 3/5. Now, again, it's the same kind of idea. The numerator is exactly the same, but the denominator is different. Again, 4 pieces means the pieces are actually larger. So So if I had 3/4, that's actually a little bit more than if I only had 3/5. This is going to be slightly smaller, just like the candy bar idea here. If I had to only share it with 4 people, but then actually maybe they don't want any, and you end up eating all 3 pieces of those fourths, it's going to be more than if you ended up with 3 out of 5 pieces. So again, that's the larger fraction. I'm going to leave these alone. I'm going to have you do them tomorrow on your own, and we'll talk a little bit about if you're having trouble with this, we could always draw in our notebook some strategies to solve them. Okay, so let's move on to number 2. We're going to compare by reasoning about the following pairs of fractions and with the same or related numerators. We're going to use greater than or less than. We're explaining our thinking. They did B for us, so let's take a look. They said 2/5 is less than 4/9. And then they showed because 2/5 is the same as 4/10. So basically they created the same numerator instead of denominator. They're saying let's compare the numerators. If 4/10 is less than 4/9, because tenths are smaller than ninths, so we talked about how the denominator 10 is actually smaller pieces. So they're showing you here how they want you to reason that. So for A, let's do A. We might do same numerator. We might actually just do same denominator. They want you to do the numerators being the same. So we'll try one with the numerators. All right, in this case, they already gave you 3's as your numerator. So they already gave you the same numerator, 3/5 or 3/4. Well, we know that if something is 5ths, those are smaller pieces than something fourths. So we know that 3/4 is going to be larger. And then we're going to explain. 5ths are smaller pieces than fourths. So 3/5 is less. So we know that 5ths are smaller, even though there's more of them, they are smaller pieces. So 3/5 is going to be less than that 3/4. All right, we're going to do D because the numerators are not the same. C, they are, so you could explain that. This one, however, the numerator, the top number, is not the same, but we could make 6/7, we could make that numerator the same. In order to make 6/7 something 12 something, I know that to get from 6 to 12, I'm multiplying by 2. Whatever I do to the numerator, I must do to the denominator. I now have 14ths. All right, boys and girls, so we now have 12/14. So now we can compare 12/14 and 12/15. Because this is 15ths and it's a larger number, it means that the pieces, there's more of them, so they're actually smaller. So we would know that 12/14 is larger. You could also do, if you wanted to double check yourself, you could do the cross multiplication, 12 times 7 and 15 times 6, just to double check yourself. So 12 times 7 is 84, and then 15 times 6, if you do that over here, you see that that's 90. 90 is a little larger, so it would make sense that 6/7 is larger than 12/15. So tomorrow we'll continue working on this lesson and solving using the same numerators. But if you are struggling, we could use some of the other strategies as well, like the tape diagram and cross multiplication. All right, have a great day, and I'll see you later.